Welcome to Store Rules 101. Today we're going to be talking to you about resistors, capacitors, and RC circuits. My name is Anthony Folks, and
Hey, bro.
yeah,
What you doing?
what are you doing? Hey,
You recording?
hey, stop. Hey, what are you?
Bro, it's a group
No,
thing.
hey, this is my shine. My shine.
It's
Me.
But
Look at
it's
this
a,
face.
it's a we thing.
Look at, it's not a we thing. It's a me thing.
Oh,
I gave you 115 seconds.
my bad.
Now
But
you
it's
can
like,
get out.
that's,
Okay. Anyways, we're going to talk to you about resistors, capacitors, and RC circuits. And first up to talk to you to introduce resistors is Felicia Black.
Woo! Hello, my name is Felicia Black, and today I will be talking to you all about resistors. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. Here is a symbol for a resistor. The circular equation for a resistor is R equals V over I. R being resistance calculated in ohms, V being potential difference calculated in voltage, and I being current calculated in amps. At this time I will show you an example. A small flashlight bulb draws 0.30 amps from its 1.5 voltage battery. What is the resistance of the bulb? Well, using the circular equation R equals V over I, V would be 1.5 volts given in the question, and 0.30 amps would be the current given in the question. The resistance would be 5.0 ohms. Thank you, and this is Resistors. Have a great day.
How you doing, everybody? My name is Malik Jalil-Naris, and I am here to speak to you about capacitors and capacitance. Now, a capacitor is a device that can store electrical charge and is usually stored on two conducting plates. With that being said, do I have any questions?
Yeah, those lines, like right
here?
there,
right
there.
Right. You want to know?
What are those?
Oh, these are for like how you draw a capacitor on like a problem, like how Dr. Stone would.
Oh,
Yeah, so like, you want to know anything else?
so that's like a symbol. Like,
Yeah, it's like your symbols. Like,
okay,
you know.
all right. And then like I'm looking at some really complicated, looks like math equations over here.
Oh,
What is that?
Oh, so this is like how you find the summation of capacitance, like within like different circuits, like your series circuit and also your parallel circuit. So basically, like I'm gonna come over here. Let me show you something. So like this right here is basically how it would like a circuit, like a mixed circuit would be drawn out with capacitors. So here you have your parallel circuit, and also here you have like somewhat of a series circuit. So with that being said, you see here with your parallel circuit, you can go back to your equation, and you see you just add them up. So you have your 8 microfarads and your 2 microfarads, so now that equals 10. Boom. Now, go over here. You have a series circuit. With that being said, you basically take these numbers and you plug it into your series circuit equation. It's like blah. So, now you got your 1/5 plus 1 over 10. Go down 2 over 10 plus 1/10. You know how you got that. Common denominators. Simple math. Now you got 3/10, you add them up, and all you got to do is just use your calculator to get the decimal point. It's like blah. Like, all this is shout out to Dr. Store. Damn.
My name is Anthony Folks, and I am back here to talk to you about RC circuits. RC stands for resistance capacitor circuit, and as the name implies, you have both a resistor and a capacitor in the circuit. Also to note, your current, voltage, and charge change with time. They are not constant throughout the circuit. We're going to move over to the formulas real quick. And for the charging, for your voltage and charge, we have these two equations right here. And then for discharging, we have these other two equations for voltage and charge. As you can see, they're both in relation to time. Another interesting tidbit is these equations are used for when you're finding the charge and voltage across for a capacitor. If you need to find the charge and voltage across for the resistor, what you would do is if you're in a charging state, you would actually just use the discharging formula And if you're in a discharging state, you would use the charging formula. So that's something interesting to take note of. Over here we have an example problem. It's a simple problem. We have a first order RC circuit, which just means you have one resistor and one capacitor here. And the problem is find the charge Q across a 5 microfarad capacitor at time 0.05 seconds in the following circuit when the switch is closed. So what we do is, can you please pass me that marker?
What?
So what we do is we're given the voltage, the capacitor, and the resistor. All that's left for us to do now before we can plug it in is to find the time constant, which is simply just the resistor magnitude and the capacitor magnitude. And 10 mega ohms times 5 microfarads, you end up getting 50 as your time constant. And then you can plug all of your lovely numbers in, and what you get is you've got 25. Oh god, my handwriting is atrocious right now. So negative 0.05 over 50, if I can write. And this will give you 0.025 for your charge. And I would like to thank you for watching this amazing video. Special shout out to Dr. Store, because Dr. Store, of course, loves the kids. And, hoping to see a little bit of that love come finals. On a serious note, though, this is the end of our presentation of our group project. Have a good one.